In this topic, we'll demonstrate how to take a peak hour factor and apply it to your simulation project. The process for doing this is slightly different depending on whether your project uses an OD matrix or turning movements as the input demand source. If you're familiar with the HCM procedures, you're probably pretty well versed in how the peak hour factor works and what it represents. Rather than assuming that traffic is steady and constant over the whole peak hour, as shown in approach B, the standard approach for HCM procedures is approach A, where only the peak interval is analyzed. In a simulation, it's better, in fact, to take approach C. This is where every single interval within the analysis period is explicitly represented with different volumes. So you're capturing the fluctuation that occurs over the peak hour factor just as traffic in the real world does. If you have count data in 15-minute intervals, you're not applying a peak hour factor because you're explicitly simulating that fluctuation that was observed. However, you may only have hourly interval data available, whether from counts or from a future year traffic forecast. In those cases, we're going to assume a peak hour factor and then apply it to the simulation so it will explicitly be simulating some distribution of demand that looks something like this for approach C. So in this same chapter, in the next exhibit, in the list of suggested default values, we see that if the volume is greater than 1,000, then you use a peak hour factor of 0.92. So peak hour factor of 0.9 means the fluctuation is a little bit greater, 0.92, not quite as much. Peak hour factor of 1 means no fluctuation. So in the OATS manual, table 7.8, a table is provided where you can look up the peak hour factor and see a suggested distribution of demands for each interval, including a warm-up period. So you can see as the peak hour factor decreases, the fluctuation, the difference between these distribution splits becomes greater. So to enter this in TransModeler, go to the sidebar, Simulation tab, open the project settings. And because we're including a warm-up period, we want to make sure the simulation period reflects that. So our start time will be 4:45 p.m. and our end time will be 6 p.m. The initial state will be empty, and then the warm-up period is 15 minutes. So this means the first 15 minutes during the warm-up period are by default excluded from the reports you generate with the Output Manager. We'll go to the Input tab, highlight the OD matrix that's used in the demand table, and select the option for trip matrix settings. By default, you'll first notice that the time distribution is set to constant over time. This is the same thing as approach B, which means the traffic is steady, constant throughout the peak hour. What we want is the curve-based option, which will enable the curve tab. What we want to do to represent this distribution of demand percentages is convert this back to what was shown initially, where we have 5 intervals. And you'll right-click those points that separate the intervals in this graph and then set them to the values shown in the table here on the left. So the second interval here is interval 1 in the simulation period, and then interval 2 is a bit higher. Interval 3 is 25%. Interval 4 we'll assume is 22.83. And you can check to make sure everything adds up. Because we're including the extra warm-up period and the extra 20% volume, the sum should actually be 120%. This is because the input that we're provided with the forecast is a peak hour volume. So since we're simulating 75 minutes instead of 60, it's okay to be set to 120% total. So that summarizes how you would set the peak hour factor in terms of curve percentages for the OD matrix. For turning movement tables, we'll come back to the project settings in a moment, but first we want to actually open the turning movement table itself. Right now we have 2 columns representing the peak hour demands for the AM and PM peak periods. What we're trying to do here is break down the total peak hour volume, splitting it into these 5 intervals of reduced volume. So we have the same, we'll end up with the same total volume, we're just splitting it down according to these splits, the same way we just did with the OD matrix. So we'll first need to add new columns to represent each of these intervals. So we'll right-click on the data view, go to Modify, and here we see all of the attributes in this table. So we want to add 5 new fields, 5 new attributes, and name them according to what they represent. Say yes, accept, and we'll see the 5 new attributes appearing on as the rightmost columns in this table. So instead of being able to just specify the percentages in a graph like we did with the OD matrix, we're actually going to just compute these numbers in the turning movement table itself explicitly. So you want to right-click the column header for the attribute representing the interval we're editing and go to Fill. In this window, we'll select Formula, and we're going to pick 2040 PM and multiply that by 20%. This message is telling us because the format is integer, it will truncate the value after the decimal. Instead of truncating the value, you could have also used a function in the formula to round the value to the nearest whole number instead. And we'll click OK, and we'll have the warm-up volumes there, and then we'll do the exact same thing for the rest. And then since interval 1 and 3 are equal, copy and paste that. So now that all 5 attributes are filled out, we can close the table and then go back to the project settings, Input tab, select the bin table representing the turning movements, and select this same trip table settings option. And we want to select multi-period. And this will make sure that all 5 of those intervals will be simulated according to the time period in which they start. So we want to select the warm-up column as the first volume field, meaning starting at 4:45. That column of turning movements will be simulated first. And then the remaining 4 intervals will follow, and every interval is 15 minutes long, so the total will be 75 minutes, which is what we want. Click OK, and you're all set.